This video is on beat. Beat reminds me of my childhood and my parents. Okay, and today I feel probably those beat made me what I am today. Okay, anyway, today's generation would say otherwise. Anyways, okay, let's get into the topic, beat. Now this beat is obviously not that beat. This is about superposition of two sound waves. All right, now let's understand the significance of beat and then let's get into derivation of beat. Okay, we have heard of a radar, which is radio detection and ranging system. We have heard of sonar, which is sound navigation and ranging system. Both are based on beats, that is superposition of two sound waves. Now let's take one example. Plane. Hope it looks like plane flying in air. Now there are lots of cloud around and the weather is really bad. The thing that helps the pilot is radar, weather radar. The wave is sent to cloud with a particular frequency. There are lots of water droplets. Then the wave returns back, but with slightly different frequency, though the amplitude of both the waves would be same. Now this creates beat. This diagrammatically I tried to represent. Now see, this is a wave which has been sent and this is the wave which is coming back. This is wave Y1, say this wave. This is red one, the one which is coming back. Assume that it is Y2. Now Y2. Alright, so Y1 sent, Y2 received. Now what had happened? Slight change in frequency. Initially it was N1 frequency, but now the frequency has changed to N2, but the amplitude remains same. So what happens? So what happens is, what we end up with is this type of wave. So there is waxing, maximum, and then minimum, maximum, then minimum, maximum, and minimum. So this maximum, whenever there is maximum, so what happens owing to this maximum is called as waxing, and minimum is called as waning, then again waxing, then again waning, and then again waxing. Now what is this called? This is a periodic variation in volume. You would find that the volume would increase and then decrease and then increase and then decrease, and then this will keep on happening. Now is this a progressive wave? If it is a progressive wave, then that would be coming to us. Alright, and if it is a stationary wave, it would remain the same. This is a thing which we are going to derive and find out varieties of things. We are going to find out frequency of beats. So beats also have frequency, right? So frequency of beat we are going to find out. We are also going to find out whether it is progressive or stationary wave. Obviously, if it is a stationary wave, then it's of no use for us. Okay, so radar we know is used for air traffic control. Weather radar we know is being used for checking out bad weather. All right, and I guess I told radar is radio detection and ranging. All right, and if we've seen ship, yes, in ship also, in huge ships also, you have to check out depth of water, send wave, receive wave, check out sonar, difference in check out the beat. How much difference is the beat? From that we get the idea about its depth. All right, much more to come, which this is just roughly I told. And then again about speed of vehicle. Yes, so how do RTOs or how do these people understand the speed of our vehicle? Now so what is done is, it is all with the help of sonar gun. So gun is not for shooting, but it is for shooting wave towards a vehicle. It goes to vehicle and returns back. So there is difference in frequency. Speed gun is set in such a way, with the help of knob, the Doppler effect, the difference in frequency could be nullified. So while doing so, a knob is being turned to remove the difference between two waves. Now while doing so, it's also giving velocity of the vehicle. So standing at one corner under the tree, hiding behind a tree in some corner of street with that speed gun, the person can find out speed of vehicle. So basically what was done was velocity of this wave was increased and brought to this. So when velocity of this wave was increased by changing that knob, so velocity of this wave was increased by changing knob. So once beat was heard no more, that was the velocity of vehicle. So speed of car also could be detected using speed gun and using beat. So from this we come to know how significant is beat. So beat is superposition of two sound waves and it requires same amplitude but slightly different frequency. And what happens owing to beat? There is waxing and waning. That is, volume max is waxing and volume min is waning. And whether it is progressive or stationary, got to find out by derivation. Alright, and then we saw few examples of radar, sonar, we saw it in airship, watership, car, and various other many places it holds application. Alright, now let's get into derivation. Let's assume two waves with displacement y1 and with displacement y2. Alright, two waves having same amplitude and slightly different frequencies n1, n2. Let us assume these waves arrive in same phase at point x. Just to make derivations easy, we eradicate the term x over lambda by assuming x is equal to 0. If we assume x is equal to 0, this term disappears, this term also disappears. So now the equation for y1 and y2 gets to this. Alright. Now as per principle of superposition, we already have seen y is equal to y1 plus y2. Alright, so we do the same thing. This part also we have already seen in our earlier video. Y is equal to this plus this. Alright. Now, isn't it in this equation, if we take a common out there, then it becomes sine 2 pi n1t plus sine 2 pi n2t. Now this follows the formula. So it would be 2 sine c plus d upon 2 cos this minus this upon 2. Now what we get is, we actually get cos later on, but that cos thing I have taken it beforehand. Cos part, and this is the sine part, and 2a is there, a which was common, 2 is of formula. Why we did this? So that we could assume this entire part to be amplitude. That's what we did. And n1 plus n2 upon 2 we got over here, n1 plus n2 upon 2, we assume that to be n. That is the mean frequency of two sounds. Alright, so the equation is y is equal to a sine 2 pi nt. So this becomes a, the amplitude, this becomes the n, the frequency, therefore this becomes the equation. So that is y is equal to a sine 2 pi nt, and this reminds us for progressive wave with frequency n and amplitude a. Alright, so finally decided. So we were a bit confused about whether the superposition of waves created progressive or stationary wave. Now we are sure that since the equation is a sine 2 pi nt, so it's a progressive wave. So that's the reason why we hear the waxing and waning, that is volume max, volume minimum, as a result of superposition of waves. Alright, and that's what is very helpful to us. Okay.